Working with our experimental probability today, one of the things they're going to sometimes ask you is, what is the, not only in a fraction or a percentage, what's the probability something's going to happen, but in words, what's the probability? So when we have them, these words should make sense to us. We should look at it and say, well, that makes sense that they would line that word up with it. If the probability of something happening is a 0%, that's impossible, isn't it? Can you give me the example of something that would be impossible to happen? Don't work below. Be with me, please. Give me an example of something that's impossible. It can't happen. It's a 0% probability.
Like D1,
Any random example?
Getting to the end of a number line.
Getting to the end of the number line. The probability of ever finding the end of the number line is 0%, because it's impossible, because it's why?
Never end.
It never ends. It goes on infinitely, forever. Okay?
there's like a 0% chance of rain
0% chance of rain.
Earthquake.
In other words, it's impossible for it to rain.
Or a hurricane.
Do they ever say there's a 0% chance to rain?
Yeah.
Have you ever heard that one? I'm not sure if I ever have. They maybe don't talk about it at all. They don't say anything about whether it's going to rain or not. But if they do think it's a possibility of rain, they give you a percent. Then they give you a percentage, don't they? Okay? So they're, I'm not sure we could ever say there's a 0% chance of rain.
An earthquake in North Dakota.
I'm not sure we could even say that there's a
Hurricane.
0% chance of an earthquake in North Dakota. A hurricane. We can have a hurricane probably in North Dakota because hurricanes come off of the
Coast, or like
Yeah, the water, and we're along the coast, we're a long ways away from that. There's a 0% probability of the sun rising in the west.
No.
Sunrise.
Sun rises in the east always, doesn't it? Yeah, so there are things that, you know what, it's just not gonna happen, it's impossible. Well then, if we talk about the probability anywhere greater than 0%, I'm gonna use X, but less than 50%, they say it's unlikely to happen. So typically, and this is so funny, because if we hear that there's a 40% chance of rain, we think it's gonna rain, don't we? But in reality, if there's a 40% chance it's going to rain, what's the probability it's not gonna rain?
Likely.
60.
60%. So what's more likely? Is it gonna rain or not rain? It's more likely not to rain than it is to rain. So 40% is in the unlikely range because there's a much greater chance of the other thing happening. So from 0 to 50 is unlikely, and then write it exactly at 50%, we say as likely as not. So it's just as likely you will flip a head on a coin as you will a tails. Nobody knows. You're standing there, you're gonna flip a coin to see if the boys get to go to lunch first or the girls get to go to lunch first. The girls call heads, and I flip that coin, it's just as likely to land heads as it is going to land tails.
Did you try that?
We try that.
No.
Okay, and then this one should make sense also. In other words, if we have is greater than 50%, but X is less than 100%, it's somewhere between 50 and 100%, we say it's likely that it will happen. It's more likely than unlikely, in other words. That 60% chance of not raining is far more likely than a 40% chance of raining. And then, of
Why do you
course,
have 400?
oh, it's just attached to my inequality symbol, so it looks like a 400, but it's really not. Okay, so let me erase my 100 and make it better. Okay. And then last but not least, this one should make complete sense also. If it's 100%, it's certain. It's 100%, it's going to happen. If you got 100% on the test, you didn't get anything wrong. It is certain that you did everything correctly. Okay? So, those are important things, that line, you're gonna have to be able to refer to it, you're gonna have to be able to understand that if they ask you about being able to, tell it in words, that you'll be able to match it up. And then, let's look at this example right here. Inspectors tested 500 cars for smog emissions. We don't care as much about smog in North Dakota, but they do in places like New York, San Francisco, bigger cities. 13 of them failed the test. 500 cars, that's important information right there. 13 of them failed the test. What is the experimental probability that a car chosen at random will fail the test? So here's this 500 cars, and we say, I'll take that red one over there, that one, I like that one, that one. Is that one good? What's the probability it would fail the test? In other words, it says they had tested 500 for smog emissions, 13 of them failed the test. In other words, they're gonna be smog producers.
Slimmed it up.
So the number of times the event occurred, it happened 13 times out of 500. So the likelihood that you would pick a car out of those 500 that would have that, smog emission problem would be 2.6%. Is that impossible?
Just slim.
Unlikely?
Unlikely.
As likely or not?
It's
Likely?
It's very unlikely.
Or certain? It's unlikely, and it makes sense to even say it's unlikely, doesn't it? We hear that word 2.6% and we can say to ourselves, that's unlikely that I'm gonna pick one of those cars. Then it says 125 cars are scheduled to take the smog emissions test. So there's another 125 that they're gonna test. Predict the number of cars that are likely to fail the test. Now you notice they use the word likely there. That's not necessarily, you go up there and say, oh, it's gonna be between 50 and 100%.
No, it's saying like likely how many of them will actually fail.
Yeah, how many could we predict
That could fail.
that could fail it? So it says find 2.6% of 125, because out of the 500, 2.6 failed. So we're gonna predict that 2.6% would fail out of the 125. And so what's this right here? What's that? 0.026?
It's 2.6%.
2.6% change to its
Decimal form.
decimal name. So we multiply the percent change to its decimal name times how many things it's going to happen. And here they rounded it to, and then what did they do here? What's that? Is that an equal sign? Is this an equal sign here on everybody's papers? Thanks. And then they rounded it to, does it come out to exactly 3 points? Would you multiply that in your calculator and find out?
Can I borrow a calculator?
What's 0.026 times 125?
3.35.
Top one, right?
Does it come out to 3.25?
Yep.
Okay, so that's what it came out to exactly. Well, we know you can't have a fourth of a car, so we are gonna round to the nearest car, and we're gonna say about 3 cars would fail the test out of that 125. Now that seems to make kind of good sense. 3 out of 125 versus 13 out of 500. Seems reasonable, doesn't it? If we'd have ended up with an answer like 38 out of 125, would that have seemed reasonable?
You recall?
If 13 out of 500 failed the smog emission test, would 38 out of 125 fail? Or in other words, let's do it like this. Would you take 125 times 0.26? Would you take 125 times 0.26?
32.5.
32.5, so about 32
2.5.
and a half cars, let's say 33 cars, okay? So about 33 cars. Does it make sense that 33 cars, okay, heads up and engaged here, you need to think like this in life. Don't just walk around like, somebody with a dead brain and let people take advantage of you. So does it make sense that if 13 out of 500 cars failed the test, 33 out of 125 would fail?
No.
Does that make sense?
No.
No. So what did I do wrong there when I said I'm going to multiply 125 times 0.26? What did I do wrong?
2.6 is 2.6%.
I did not change the decimal properly. If this is the decimal name for 2.6%, and I only move it back one place and say it is 0.26,
I was saying it's 26%.
that is saying it is 26%, isn't it? So when we get our answers, I keep trying to, do this. I say, make sense. Say, does this answer even make sense? Because it's really easy to change percentages, and this is what will happen to you when we're working with probability. You will not change the percentage to a decimal correctly, and you're just gonna be happy you got an answer, because your calculator was still working, or my calculator you borrowed from me was still working. Okay, let's try one on our own here. A machine assembled 600 boxes. An inspector notices that 594 of the boxes have no defects. Okay, that's kind of important information. 594 have no defects out of 600. Okay, so now what's the first question they want? What is the experimental probability that a box chosen at random will have no defects? What's our
594 by 600.
So first thing we're going to do is we're going to put 594, that's how many have no defects, over the 600 total.
It's 99%.
And we're going to change that to a percentage and divide it out, and you said it comes out to 0, I bet it comes out to 0.99,
Yeah,
and then that equals
99%.
99%. Does that seem like a reasonable percentage?
Yeah.
There's
Yeah.
only like 6 missing.
Yeah, there's only like 6 missing that didn't have defects. 6 had defects, in other words. So, you know what, that seems reasonable. Is this event impossible, unlikely, as not likely, or certain to occur?
Like,
It's likely, because that percentage is between
50 and 100.
50 and 100. So it's likely that boxes will not have defects from this machine. The machine's working well. Okay, now the machine assembles 800 boxes. So new, it's got these 600s already done them. This is what we found out. 99% of them don't have defects. Now that it's going to assemble another 800, predict the number of boxes that will have no defects.
0.99 times 800.
So we have to do 0.99 times 800.
792.
Does it come out to exactly that?
Yeah.
Okay. And let's write a sentence here. We are going to predict, we're going to say 792 boxes will have no defects. So how many would have defects? 8. What percentage would have defects? 1%, yeah, the other part, the 99 taken away from 100. So this is our prediction. Does that mean that will happen? For sure? No, this is based on experimental probability. Based on what happened before, we're saying this is what we think will happen next time. Okay, so it's a prediction that we just made, that 792 boxes should have no defects. That would maybe be a better way to say it. Okay. The owner of a vending machine kept track of the number of times the machine dispensed change incorrectly. They should do it this way instead. Number of times that you didn't get the item you put your money in for. Right? Has that ever happened to you?
Yes.
Happens to me all the time. So this is, it didn't give you the change it was supposed to. So whatever you bought was actually 75 cents. You put your dollar bill in the dollar thing and it didn't give you back a quarter. So you just paid $1 for it instead. So the owner kept track, and out of 13 he found that the change, let's underline that, change was incorrect 13 out of 325 purchases. So 13 times out of 325 times, the change was incorrect. Okay, number 8, what is the experimental probability that the machine will dispense incorrect change?
13.
13 out of 325. Let's divide that out and change it into a percent. 0.04, which is 4%. So there's a 4% chance that if you are buying something from that vending machine, you're not gonna get the right change. Is that impossible, unlikely, as likely as not likely, or certain? Unlikely. It's unlikely you're gonna get ripped off. Mad because you paid more for it than you were told you were gonna pay for it. Okay, C, 25 purchases are made at the vending machine. So here, next 25 purchases, predict the number of times the change will be incorrect. What is your
0.04 times 25.
0.04 times 25?
One.
1? Because 4 quarters are in a dollar, right? That makes sense. Okay. Does that seem reasonable, that answer? 1? If it was 13 out of 325, 1 out of 25, does that seem reasonable? So we would say 1 times.
The change will be incorrect.
1 time the change would be incorrect. Only 1 time. Okay.
We need to,
But make sure you're showing like we did here though, okay? Everybody just make sure that what you're showing, you do it on the line, kind of like we did here.